All right, welcome back. We are going to begin our conversation about the inverse trigonometric functions. And you'll remember that the inverse of a function is essentially that function turned on its side. So for example, if we're talking about the function f of x equals x to the third, it looks like this, right? And you'll remember that its inverse looks like this. And that is the function that is f inverse of x equals cube root x, or we can also remember, right, that is x to the 1/3 power. Now, the thing to remember is that these two functions are mirror images across that green line, which is the line y equals x. And we remember that for functions for which their inverses are also functions, f inverse of f of x equals f of f inverse of x, which equals x. This is the very definition of the inverse relationship. So what we do for trigonometry is we define inverse trigonometric functions. And we call them quite simply sine inverse is the inverse of sine. And sometimes we write that as arc sine or a sine. These all mean the same things. These are the inverse of sine. We will talk about the inverse cosine, which can be written as arc cosine or a sine, and inverse tangent, which can be written as arc tangent or a tan. So this is the inverse, whoops, my bad, cosine. Inverse of cosine and inverse of tangent. And we can also talk about inverse secant, inverse cosecant, and inverse cotangent, although we don't tend to do so. Now, what we need to do, though, is remember that in order to make them functions, we have to do some work. So consider sine. Consider the sine function. And if I just pull in a quick graph of sine, so y equals sine, it's not really what I want, doesn't really matter, but we're going to talk about sine because I started there, sine x. Now, what happens if I turn that on its side? And you'll remember from other classes that one of the ways that we can find, in fact, the way that we find algebraically the sine and cosine for algebraic functions is we swap x and y's. And that works, and that will work for my purposes here. So that blue curve is indeed an inverse of the sine curve, but what's the problem? The problem is it is not a function. So in order to get around that, we limit the domain of our sine function. And what we do is we limit our domain to x's between negative pi over 2 and pi over 2. This gives me then a function. So this is I limit my sine to this, and if I then, let's see what Desmos does here. Look at the inverse sine. My inverse sine by definition, so notice that on my inverse sine I did not have to give Desmos any limitation, because the inverse sine function is defined to be the function that undoes sine, but only within negative pi over 2 and pi over 2. So what we're saying here, so in order to make, so we must limit the domain of sine in order to ensure that the sine inverse is a function. And we must do that for both cosine and tangent as well as for sine. And so what we've done is, by convention, we have decided, we being the math world, that sine is limited to negative pi over 2 to pi over 2. What that means is, if you think in terms of your unit circle, we are talking about only this half of the unit circle for sine. Okay? Cosine is limited to to 0 to pi, which means if we talk about this in terms of the unit circle, when we're talking about cosine in terms of its inverse function, we're talking about only the top half of our circle. And we similarly limit tangent to its first appearance through the origin. So that means from negative pi over 2 to pi over 2. Now here's the deal. If theta is in the right region, so if negative pi over 2 is less than or equal to theta, is less than or equal to then, and if sine theta equals some number, then if we take the inverse sine of that value A, we're going to get out an angle. So that's the kicker here. Trigonometric functions apply to angles and give us ratios, values. Inverse trigonometric functions are applied to those ratios and give us back angles. Okay? And if my angle is between 0 and pi, and if the cosine of theta is equal to a value, then the inverse cosine of that value gives me back that angle. All right. So what we've done is we have said that the inverse sine, so I'm going to do this. I'm going to do function, and I'm going to give you a domain and a range. For if my function is inverse sine x, inverse sine is only defined over the right-hand side, of your unit circle. My bad. The only values we can put into an inverse sine function are values between -1 and 1. Because those are the only values we're going to get out of a sine function. And you'll remember the relationship between the domain and range of a function and the domain and range of its inverse. The range of inverse sine is negative pi over 2 to pi over 2. In other words, if I put a value into Desmos and ask it for it's the inverse sine, I'm always going to get something between negative pi over 2 and pi over 2. And we'll see in a little bit why that's a problem, because that might not always be the angle we want back. And we'll talk about that. Inverse cosine, again, has a domain of negative 1 to 1. Those are the only values we can put in. And it's got a range from 0 to pi. And inverse tangent has a domain of all real numbers and a range of negative pi over 2 to pi over 2. Now, put some thought into why I used a non-inclusive interval on that last one. It is not arbitrary. Okay, so let's talk about, well, let's stop here. This is enough for this video. I'll come back in a subsequent video and we will apply the inverse trigonometric functions and do some examples.